I'm just going to introduce a few more concepts from the IPCC. Obviously, we are a little bit away from the core of the course, which is ocean atmosphere dynamics. But since the last chapter in the book mentions global warming, and it is such an important topic, and I started into IPCC, I'll just show a few more things, including human behavioral aspects. Okay, you can skip these if you want. So IPCC defines 5 reasons for concerns, RFCs as they called, unique and threatened systems, extreme weather events, distribution of impacts between groups and between regions, global aggregate impacts, and large-scale singular events. Okay, economists would typically worry about return on investment for everything, including spending on climate action, for example. But when IPCC negotiations happen with so many countries involved, the languages are picked very carefully. So the scientific results have to be presented in these policy-oriented language with qualifiers, selected qualifiers like virtually certain, very likely, about as likely as not, unlikely, very unlikely, exceptionally unlikely, based on the best estimates of probability of events. That's something you have to keep in mind. So you can see here warmer days and nights, more hot days and nights, and so on, more drought, etc. go from very likely contribute assessment of human contribution to observed changes, 21st century changes, and so on. So the table looks like a mishmash of few very likelies and few more likely than not, and so on and so forth. So policymakers have to decide. Unlike scientists, they have to make a decision and they have to pay a price, let's say in terms of elections, whereas scientists can just say what is important and what are the options, what the models say, and then they are not responsible for the decisions made. Okay? So this graph presents a future increase in temperature on this side and various time horizons on this side from the 1990 baseline to 2025, 50, 75, and 2100. As I said, decision horizon of 2100 is not very clear. 25 is right here, so obviously matters. 2050, long-term strategies probably do require this kind of time scale. And the systems RFCs again, risks to unique and threatened systems, frequency and severity of extreme climate events. Obviously this is a very regional thing. Could be hurricanes, cyclones, typhoons, could be extreme rainfall events over India, extreme heat waves, inundation, storm surge, and so on and so forth. Global distribution and balance of impacts, you can look up the definition. Total economic and ecological impacts, and risk of irreversible, large-scale and abrupt transitions. I will show one heuristic argument about the tipping points in the system. So you can think of abrupt, irreversible transitions as switching to a regime that you cannot come back from. Let's say, like as we mentioned, the disappearance of the Greenland glacier, or collapse of the Amazon forest, maybe collapse of the monsoon, etc. Okay, so the various things have various estimated risks. So in the early horizon there is risk to some and risks to many. In frequency and severity extreme climate events, which is studied a lot because there is a lot of interesting physics behind it. So it is something not necessarily just social science, it's actually natural science. So expected to increase with these climate warming scenarios, and there are going to be large increases if you warm to these levels. We have discussed how extreme events happen in a very brief heuristic argument using the example of a sponge, atmosphere warming and loading up with moisture and like a sponge, and then when you squeeze it, it's going to pour somewhere. But there is plenty of evidence across the world that extreme events in terms of rainfalls, snowfalls, even droughts, flash droughts, have increased already. There is clear evidence of that. Negative, so the third system is global distribution and balance of impact. So you have to see here distribution of impacts. Risks are unevenly distributed between groups of people and between regions, and global aggregate impact. So as I said, global warming is already creating winners and losers, and it will continue to do that. At some point when we reach extreme warming, maybe everybody pays a price. But there are subtle impacts that affect people without them realizing. For example, if sea level rises and the Bangladeshis have to move somewhere and they become climate refugees into India, or if there is a climate disruption in some country like Somalia and they become pirates or they become extremists, just those sorts of things where it's not easy to directly link climate to the impact, but these things do happen, and there are agencies and scientists who study these things. So there will be negative impacts for some, but as the warming happens, it will be negative impacts for most people. This is fairly obvious. And the total economic and ecological impacts, positive or negative market impacts, majority of the people will be adversely affected. Here again, it depends on what it is. For example, with warming, India wants, let's say, lots of air conditioners. Paris Agreement says HFCs have to be phased out by 2030 by the rich countries, and developing countries like India will get longer time. But the main thing is, what will replace HFC? Who will invent it? How will countries be given access to it, and so on. So it's complicated. Net negative in all metrics for future increases, and of course in the risk of irreversible large scale and abrupt transitions. Right now they are very low, but they get higher. So this remains quite uncertain in terms of its risks, because we are not very good at predicting these things. There are groups which consider tipping points a lot, and they make heuristic arguments of tipping points in the system. We'll look at one map of it. But I myself am not comfortable with it because models cannot really predict them. So claiming the tipping points and how quickly they arrive, Arctic sea ice, for example, can be expected to disappear if warming continues, but when? And what are the actual impacts of Arctic ice melt? Already there are many scientific evidences for it, but how do you say when it will happen, and what are the uncertainties associated with that, and so on. So in general, these tipping points, switches, thresholds, and so on are more uncertain than I think the models can really depict at this point with the current understanding we have. Okay? That's something you have to read up and decide for yourself as well.